we're back to that. Another test here, we talked about fatigue testing, or a test where things happen over and over and over again. Again, the Sharpie test is a dynamic test. It's a crash test. This is a fatigue test, where we're going to try to stretch something multiple times and see how long it lasts. This one sort of looks like a universal testing machine, a UTM, because of the way that it has these grips pulling this apart in tension. But let's see what this guy has to say. So I stopped it for a few seconds. You notice they put this accessory on inside here. This is a little tiny machine that actually measures the necking down while this thing is under tension. It's kind of cool. We talked about necking down inside the other Prezi as far as a cartoon of these things getting thinner. Now you can actually measure it. So I'll be quiet and get out of here. So this one is an oven. They're going to go ahead and put the sample inside here, and this oven fits around the UTM, and they can go ahead and heat the sample while they measure all this stuff in the middle as well. Okay, so enough of the awesome soundtrack. I'm ready to get out on the dance floor. I'll push a few buttons here. So obviously this commercial or this video was about this UTM that has lots of accessories on it, and they were doing some testing where they were doing some tensile testing, and you saw later on a flexure test. And then in addition to doing it at room temperature, they could also do it at particular temperatures that they could set the oven to. That was at 600 degrees. So there's other tests, and in addition to doing tests, in the lab, other times we need to do tests, out for real. And one of those series of tests that have been published is all the testing that we did back in the 1950s and the early 1960s, specifically with breaking the sound barrier and trying to get supersonic flight. One of the testing things they had to worry about was you notice that this picture here of this small vehicle, which is pretty much just a rocket with a rocket engine out the back. It has a pilot, has extremely small, stubby little wings, and the question was, these are made out of specific metals and alloys, but once you're going up around 700, 800 miles an hour, and things start to flap around, will these things flap off? I mean, gosh, you don't want the pilot to lose the wings of the aircraft while they're flying it, so they had to be tested. So a couple videos here of doing some testing of some materials inside wind tunnels, and then later inside actual test vehicles to see what happens when the wings start to flutter. Will it survive or not? Which is pretty cool. So again, the sort of the moral of the story for all of these testing videos that we're going to see is design some sort of test that will allow you to test your material in as close as, or maybe even harsher than, the environment that you plan on using it, and then see how well it holds up. We already saw the Boeing 777 wings being folded almost in half, 150% flexure, just to see what would happen if the actual production aircraft ever had to deal with that. So here's a very, very old video. 1957, you'll see, of a flutter test for the X-15 of one of the rudders. I don't think there's any sound to this, so we'll see. So this is down at Langley, in Langley, Virginia, inside a wind tunnel, and they were able to have the wind tunnel produce Mach, faster than Mach winds, which is somewhere around 800 miles per hour, depending on the temperature and the density of the wind. So here's a little tiny wing that's in this wind tunnel, and as it goes, you're going to see it start fluttering up and down. And of course, the idea is to see if it to see how well it holds up. You see here it says M164 or Mach 1.64. So that's almost 1,000 miles an hour. You can see it starting to fall apart. And I think in this video it may even actually just fly off the machine. And we're gone. So it fell off. So they stopped the video, and I'm not sure why the video here we go again, and they stopped. So they stopped the video after the runs themselves. The material itself sort of fell off. This one's not in focus. There, it broke. So you can imagine if they successfully got this aircraft with a test pilot inside of it. If you're familiar with Chuck Yeager, he's the first American to successfully break the Mach speed of sound test. You'll notice all these parts are just falling apart. You wouldn't want your test plane, your X-15 experimental plane number 15, your X-15 falling apart in high winds. So this is a test again, but this time they're actually using real wind rather than using a UTM to test this. So we'll keep on going. So it turns out that not only way back in the 1950s and 60s were they doing flutter tests, we also do flutter tests these days, modern tests. Here's a development of the Airbus A380, which is as you can see pretty quickly in this little preview over here, is a double-decker passenger plane made by Airbus. If you're familiar with airplanes, the Boeing 747 has been around for a few decades. It has very, very famous 2 stories or 2 floors near the front of the plane, and then only 1 floor. The Airbus A380 has 2 full decks and can hold a whole bunch of passengers. But of course, this needs to be tested. So this is a more modern video of folks at Airbus over in Europe testing the flutter on the Airbus. Take a look at this guy.
Big day. Today there's no more playing around. It's one of those flights that you complete one time in the entire life of the airplane. And you're much happier when it's over.
The flutter test is the only test where the flight crew must wear parachutes, helmets, and orange jumpsuits to aid identification should the worst happen.
It's a very risky flight because we are truly pushing the flight envelope. Obviously, we must wear safety equipment, which will help us evacuate the aircraft if there is any type of problem, a loss of control or something like that. But it's more to reassure us and to reassure the authorities, because if there is a real loss of control, I don't think we'll be able to evacuate the aircraft.
While the aircraft makes its way to a test area over southwest France, the monitoring equipment on board is already sending back information to the staff manning the telemetry station. Here, ex-pilots, engineers and specialists study and analyze every imaginable parameter of the aircraft. Nearly 150,000 parameters are monitored every single second. Former fighter pilot Daniel Giraud-Sauver is the director of the A380 telemetry station.
When you're in telemetry, we are living the moment. We hear the flight test engineers, so you are in the aircraft. So it's very important to follow up all the tests in telemetry, because we can help the flight crew, flight member, flight test engineers and to optimize the flight test campaign and to be sure of the results of the flight test campaign.
To achieve certification, the A380 must reach just below Mach 1, the speed of sound, without experiencing abnormally strong vibrations. The only way to achieve this speed is to climb to 38,000 feet, then descend as rapidly as possible. It will take them several attempts, as increment by increment, they edge ever closer to a speed just below the infamous sound barrier.
Ready? Okay, 3, 5, 9, 1.
As the aircraft reaches its first major speed outside the flight envelope, Mach 0.89, the cockpit begins to shudder, but the flight crew know that this kind of vibration is normal. The A380 has survived its first extreme test. Now the flight crew and engineers feel safe to push on towards the more dangerous speeds. Somewhere over the Atlantic Ocean, the A380 inches its way towards its target speed. Mach 0.92, Mach 0.93. But suddenly they hear a noise. Chief Test Pilot Jacques Rosé has felt a twitch. After a quick consultation between the air and the ground, the flight crew decide to immediately halt the test.
Very nice.
As soon as the A380 touches down, the crew hurry under the aircraft, where they quickly find the source of the problem. Because of the extreme vibrations, a large section of the undercarriage has become detached. Aircraft 1 will have to go to the hangar again, causing yet another delay that Airbus could definitely do without. Toulouse, southwest France. The Airbus A380, the world's first super jumbo, has suffered a giant setback. During a series of flutter tests, the test flight team set out to ensure that the plane could reach its ultimate theoretical speed of Mach 0.96. But at Mach 0.93, a large section of the undercarriage nearly tore off the bottom of the plane, forcing Airbus engineers to come up with a major redesign of the entire section. The operation has caused another setback in the arduous 15-month-long flight test campaign. Now, with the renovation coming to completion, Aircraft 1 can finally resume the highly dangerous tests.
There's a lot of unknowns. We haven't been there before, so all we have is the predictions and the tests done by the design office. And now all that is only predictions, and now it's up to us to go and see what the real airplane has inside.
After a final ground check, the A380 test flight crew set off for what is without a doubt the most dangerous flight of the whole campaign. Back in the telemetry room, everyone is manning their post. They all know that failure is not an option. As the flight test crew push the A380 towards Mach 0.96, the slightest abnormal vibration could cause serious damage, or even complete destruction of the aircraft. Mach 0.94, Mach 0.95. The A380 begins to tremble relentlessly, but with the aircraft holding together, the crew members try to shake off their nerves. Reassured that they can attempt the final push, the crew takes one more dive. Within seconds, the aircraft hits the ultimate speed of Mach 0.96.
je pense que là, vu ce qu'on a vu, ouais, c'est sympa, hein.
In the telemetry room, the engineers celebrate the fact that their aircraft is now flutter test certified. And with the plane back on the ground, the test flight crew can finally breathe a sigh of relief.
Je suis bien content. Je suis bien content.
Oh, Fernando, are you happy?
Oh, very happy, very happy. We took good care of him. Eh? He took good care of us also.